Hello everyone. Just want to make a short video here to show you what you can do in CalcPlot3D if you're interested in playing around with lines and planes. So we're going to start with lines. And so for lines, you want to go to add a space curve to your graph. So again, if they're in 3D, then this is the way you want to go. And they are naturally set up in parametric equations, right? So it's got the x, y, and the z coordinate separate. So I'm going to do 1 minus 3t for x, 2 minus t for y, and negative 1 minus t for z. And you can see this is just kind of low, so I'm going to zoom out a little bit until this is a little bigger. And so I'm just going to set that spin around. It looks like a line. Press home. That gets me right back. You can just, again, move it around with your arrow keys. So if you want to, for instance, check and make sure this does go through the point that it should, right? So it should go through 1, 2, negative 1 here, just from reading that off. We can also add a point. And so I'll add the point 1 to negative 1. And we do indeed see that that goes through there. So that checks out. And then, you could add the vector and see that the direction vector goes along as well. So our direction vector in this case is negative 3, negative 1, negative 1. And note, right, this has initial point 0, 0, 0, so that starts there. But if you wanted to put it at the initial point that we used, then you see that this is right along our line. Okay, so that's one thing you can do. Now I'm actually going to remove those. So something we did in class was check if our lines intersect. And so I'm going to add a second line. Now in class we used s, but this does require you to use t. So 11 plus 4t, 1 minus 3t, and 3 plus 2t. And you can see this guy. Now here I'm actually going to restrict to primary color just so it's a little bit easier. And then I also want to do that with this one. Okay, so it looks like they intersect, but it can be, a little challenging. So when we actually solved for s and t, we found that this point was 7, 4, 1. So let's see if that actually checks out here. 7, 4, 1. And yeah, that is the point that we want. And it does look like they intersect. However, they don't necessarily interact at the same, or intersect, like if you view these as particles moving, then their paths cross, but they don't collide. And so you can see this because this guy along the blue passes through right about there. It's actually at about negative 1. I just went over ever so slightly. The other one, so I'll stop animating, passes through. Boom, 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 slowly, 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 and right about there, it's around negative 2. And so they do work at different times, so they cross the point at time negative 1 and time negative 2. So you can use this trace thing, and you can change the bounds however you like, so that you can see how you move across your line as time changes. Okay, so let's go to planes. So I'm just going to click the refresh here. So planes, you want something entirely different. So you can, if you have solved for z, you could just put it in terms of z equals. However, a lot of times, right, we have like our scalar equation or our standard form. And so for that, you want to go to implicit surface. That way you don't have to solve for z necessarily. And so I'm going to look at the plane x plus 2y minus 2z equals 7. Again, this is kind of down in the corner, so I'm going to zoom out a little bit. And so this is my plane. So this is one where it's kind of nice to see maybe a normal vector, but we're actually going to wait a little bit. So something we did, or something, I got this from some problem. If I wanted a line perpendicular to this plane, so with the same normal vector, but through the point 2, 0, 2, then I could go do my space curve. So I want 2, 0, and 2 as my coordinates, and then I should have, for my normal vector, that should be my direction vector if I want it perpendicular to the plane. So plus t, because I have 1, then 2t, and then this is minus 2t. I'm going to make this a constant color. And you can see that this is hitting at a 90-degree angle. We can also check that it goes through the point 202 just to make sure. It does. And if you wanted to see that the normal vector kind of checks out, then we can again add a vector. So our normal vector here should be 1 to -2. So I'm going to make this, I don't know, let's say green. That's a horrible choice. Let's say blue. So that's very small right now, but you can see indeed that this is perpendicular to the plane. Now that one points down, so it's not, pointing down along our line, and it's not originating from a point in the plane, but you can see that it is the right direction. It is orthogonal to our plane. Okay, so that's all I've got there, and I'll make another video here about parametric functions.